Greetings to you all. In this video, we are going to discuss about 0-1 knapsack problem. What is 0-1 knapsack problem? The definition goes like this. Given n items of known weights W1, W2, etc. Wn and values V1, V2, etc. Vn and a knapsack of capacity W, finding the most valuable subset of the items that fit into the knapsack. So here we assume that all weights and knapsack capacity are positive integers and the item values do not have to be integers. Example for this 0-1 knapsack problem. Consider a scenario in which a thief is going into a house. So the main aim of the thief is to steal the most valuable items that can fit into his knapsack. If he is having the knapsack of capacity 15 kg, then he will select the most valuable items that can have the 15 kg and also most valuable. Okay, the profit, the value of the items that he would select will be the most high. And another example, a transport plane that has to deliver the most valuable set of items to a remote location without exceeding the plane's capacity. The problem states, which item should be placed into the knapsack such that the value or profit obtained by putting the items into the knapsack is maximum. Okay, and the weight limit of the knapsack should not exceed. So the knapsack problem has the following two variants. There are two different types of knapsack problem. One is fractional knapsack problem and another one is 0-1 knapsack problem. So in this video, we are going to discuss only 0-1 knapsack problem. Right? The fractional knapsack problem is continuous and 0-1 knapsack problem is discrete. In discrete, either you have to select all the items, either you have to select an item completely or leave it completely. Okay, here items are indivisible. For example, if you have some 10 kg of item number 5, then you have to either select all 10 kg or leave all 10 kg completely. You cannot divide this 10 kg into 5 kg and or 3 kg, or you can take either 8. It's not like that. Either total 10 kg or leave it. So the items are indivisible in 0-1 knapsack and it is solved by dynamic programming approach. So dynamic programming approach, the mathematical model of the 0-1 knapsack problem can be expressed as maximize sigma 1 to n vi xi. So vi is nothing but the values of the item and xi means item 1, item 2, item 3, whether it is included or not. So this xi can take the value either 0 or 1. Okay, if it is 0, we will not choose that item. If it is 1, we are selecting that item to put into the knapsack. And subject to the condition. What is the condition is here? The capacity, the knapsack capacity is W. So, the items you have selected, okay, the weights of the items you have selected should not exceed the capacity of the knapsack, that is W. So the weights of the item should be less than or equal to W. And xi is a binary variable. It is either 0 or 1. So here we have to maximize the values subject to this condition. And the dynamic programming is a technique for solving problems with overlapping subproblems. When a problem is overlapping with other subproblems, then you can make use of this dynamic programming. So, which means if you want to solve a problem, okay, so step-by-step procedure is applied in dynamic programming. Step 1, step 2, okay. To solve this step 2, you should solve this step 1 in prior, okay, in prior. So step 1 solution or the results will be used to find the solution in step 2, okay. Step 3 will use the solution or the results obtained in the previous step 2. So it's like that. So typically these subproblems arise from a recurrence relating a given problem solution to the solutions of its smaller subproblems. So consider there are 10 items. So we are not going to consider all the 10 items at a time or simultaneously. First we will consider the first item and next item, third, fourth, fifth. So something like it goes on like that. So rather than solving the overlapping problems again and again, this dynamic approach suggests solving each of the smaller subproblems only once, and recording the results in a table. So for dynamic programming, we are going to have a table. We will record all the results in the table. So in order to find the ith iteration, okay, or ith row, you will have this I minus 1 row. Okay, so this row result will be used to find the ith row. To design a dynamic programming algorithm, the main thing we have to do is deriving a recurrence relation. How the previous result is used to solve the current situation or current iteration. So we have to find the recurrence relation. Recurrence relation is main thing in the dynamic programming. Okay, for example, you have already known the Fibonacci sequence. Okay, Fibonacci sequence. So if you want to find the ith Fibonacci number, you should know the I minus 1 and I minus second. Okay, I minus 2. The previous two numbers, I minus 1 and F I minus 2. So if you want to find this I minus 1, you should know I minus 2, I minus 3, something like so. The previous numbers, okay. So that is the recurrence relation. So here, let us consider an instance defined by the first I items. 1 less than or equal to I less than or equal to n with weights W1 to Wn, values V1 to Vn, capacity I 1 less than or equal to J W. So I variable is used for the items, J variable is used for the weights, Wt. These variables will be used for to represent the values and weights. And f of ij is the table, two-dimensional array. Okay, be the value of optimal solution to this instance. So we can divide the subsets, okay, for the first items. When if you have like 1 to 5 items, 1, 2, 3, 4, 5 items at a particular stage, okay, when I takes the value 3, and whether you have two categories, whether you have included this, whether you are going to include this third item or not. Okay, whether you are going to include the fourth item or not, whether you are going to include the fifth item or not, that you have to find out. Okay, so among these subset, whether it is going to be included. If it is not included, then the optimal subset will be the previous one, f of I minus 1 comma j. If this ith item is included, then you have to find the maximum value of two values. One is f of I minus 1 comma j and another one is vi plus f of I minus 1 comma j minus wi. So if we see this recurrence relation, you will easily understand. So recurrence relation formula, f of I comma j. Okay, the row and column I, j. You have two possibilities. One is the current weight. This is the current weight. Okay, 1, 2, 3, 4, 5, etc. Something like. And this is weight of the ith item. Okay, the current weight minus weight of the current item is greater than or equal to 0, then the maximum of these two value will be assigned to f of I comma j. The previous row value, I minus 1. I represent row, okay, the previous row, and V1, the value of the item I plus the previous row values, okay, previous row, and the column will be calculated by this formula. Okay, so if it is greater than 0, if j minus wi is less than 0, the previous value will be assigned to f of I comma j. Okay, initially, this table f table will have 0 values for all 0 row and 0 column. Okay, so we are going to include 0 item 0 in the table. So here 0, 1, 0, comma 0, 0, comma 1. 0, comma 2. This will have the 0 value. And here 1, comma 0, 1, comma 1, 1, comma 2. 1, 0, comma 0, 0, comma 0, 1, comma 0, 2, comma 0 will have the 0 value. And our goal is to find f of n, comma w, the last value. Okay, so this is just in order to find the tabular representation. In order to find this f of I comma j, you have to know the previous f I minus 1. You have to consider this value and f of I minus 1 comma j minus w. In that row, this will be somewhere else in that row, and vi plus this value. So you have to find the maximum value. When we do the calculations, you will come to know and you will understand. And this is the knapsack problem algorithm. So W, the notations are given. W, capital W, the capacity. N, okay, N, number of items. So table F, two-dimensional table. W2, weight, W plus 1. Because we are going to include 0, so W plus 1. Val, another array which represent values. N plus 1. Number of items plus 1. And input the table F, WT, value, N, capacity. Okay, for I is equal to 0 to N and for J is equal to 0 to W. Okay, here you have to do begin I is equal to 0 and J is equal to 0, F of I comma J is equal to 0. Else, based on this recurrence relation, this algorithm is designed f of I comma j, etc. Okay, and return f n comma w. This is the last value we are going to find in the table. The last value, nth row column. Here is an example. Okay, consider this is the problem. Here you have to find the knapsack problem. So here item 1, item 1, the weight is 2, value 12. Second item 1, 10, 3, 20, 2, 15. Okay, and the W, capital W is the capacity. Okay, capital W is 5 kg. Let us assume it is 5 kg. Capital W is knapsack capacity, capital W. And here this is the table. You have to include 0 also. 0 here. 0, 1, 2, 3, 4, 5. And here the item 0, 1, 2, 3, 4. 4 items. And the value of each item. And the W, weight of the each item. Right? So here I have given you the index 0, 0, 0, 1. In order to complete the algorithmic steps, I have given you this index so that you can easily know which values are used to calculate the f of I comma j. Okay, so here you put 0. Okay, first step is you have to see, listen, initial condition f of 0 comma j 0 and f of I comma 0 is equal to 0. So put 0 here, 0, 0. And here also 0, 0, 0, 0. Okay. And next you have to find this 1 comma 1, 1 value, f of 1 comma 1. So for this you have to check this one, 1 comma 1 is equal to max of f of I comma 1, the previous value 0, okay, comma, the maximum of 0. Anyway, but to find f of 1 comma 1, consider the weight only 1, 1, okay, 1. Here, item 1, the weight is 2. Weight is 2. So, you cannot include this item. You cannot include the first item. Why? Because the weight is, here the weight of this item is 2. But the weight to be considered is 1. So, put 0. Put 0. Okay. And next, here 2. The weight to be considered is 2. Okay, 2. Here the weight of the first item is 2. So you can put this item into the knapsack. So here you can write 12. Okay, 12. And again, if you consider this 3, okay, the item, the weight is 3. 3. Here the weight is 2. So you can put the same because all the other items are also 12, 12. Because you are considering only the item 1. 1. Only you are considering the item 1. So the maximum weight you can put into the knapsack is only 2. So 12 is the value. And next come to this 2 comma 1. Okay. So 2 comma 1. Here, okay. So here you write all or 1 comma 1 0. Here 12, 12, 12, 12. Okay. So here f2 comma 1. So 2 comma 1 you have to apply the formula f of I minus 1 comma j. So 2 minus 1 comma j 1 comma 10. 10 is the value of the item. Value of the second item. We are considering the row 2. Okay. Second item. Second item value is 10. 10. So 10 plus f of 2 minus 1 comma. The value here is j minus wi. J minus wi. So here j is 1. Okay, 1. 1 minus wi. So the w, the weight of this second item is 1. So 1. So here f of 1 comma 1. Okay. Comma 10 plus f of 1 comma 0. That is f of 1 comma 1 is nothing. See here 2 comma 1. Consider this item, the previous one, 0 comma 10 plus f of 1 comma 0. F of 1 comma 0. 1 comma 0 is this one, 0. 0. So the maximum value is 10. So put 10 here. Okay, the maximum of 0 comma 10 is 10. Put 0. Put 10 here. And here 2 comma 2. See 2 comma 2. So I will write here 2. Again the same one, no? To 2 minus 1. 2 I minus, see listen, I minus 1. I minus 1. So I minus 1 means 2 minus 1 comma j. J is 2. Okay. Comma v. So here you have to consider the value V2 for this V2. 10 plus f of 2 minus 1 comma j. J is, so this one, j is 2. 2 minus w. So 1. 1. Okay. So this is f2 minus 1. F of 2 minus 1, 1 comma 2, comma 10 plus f of 1 comma 1. So f of 1, 2, nothing but the previous. Okay. So 1 or 2 will be very difficult. Then you can understand 1 comma 2. 1 comma 2 is this one, 12, comma 10 plus f of 1 comma 1. F of 1 comma 1 is 0. So which one is greater? 12. So here also you will have 12. You will have 12. And next 2 comma 3. Okay, so 2 comma 3, this one. So 2 comma 3, 2 comma 3, this I will write here, f of 2 minus, again 2 minus 1, 1, comma 3, comma 10 plus f of 1, comma j minus w. So j 3. Okay, so here it is 3 minus 1, 2. So 2. So which is nothing but maximum of 1 comma 3. 1 comma 3 is 12. So you can directly write 10 plus f of 1 comma 2. The previous row 1 comma 2, 12. 12. Okay, so 12. Here 22. Which one is maximum? 22. So write 22 here. Okay, 22. And for this also, for this 2 comma 4, what you should consider? F of 1 comma, okay, for this 1 comma j, 1 comma 4, comma 10 plus f of 1 comma 4, 4, the weight is 4 minus 1, 3. So 1 comma 3. So which is 1 comma 4, what is the value here? 12. 12 comma 10 plus f of 1 comma 3. 1 comma 3 is 12. So here also you have 22. Okay. And similarly, here also you will have 22. This value will also 22. Okay. So here f3 comma 1. So here I is 3. So for this calculation I is 3. Vi is Vi. The value of the third item. Value of the third item is 20. And W. Okay. Wi is 3. Okay. Wi. Yes, 3. 3. Okay. Having this value, calculate 3 comma 1. First 2 I will calculate. So 3 comma 1, maximum of I minus 1. So 3 minus 1, 2 comma. Okay. J 1 plus V3 plus F of 2 comma the weight. Okay. The weight to be considered is J. J is 1. So 1 minus 3. Here 1 minus 3. 1 minus 3 is negative value. See, negative minus 2. So which is less than 0. So for this you should write the previous one. The previous one, f of 3 comma 1. The previous one is 0. 1 0. Okay, 1 0. So here also the weight 2 and the weight is 3. So when you subtract this 2 minus 3, then you will get minus value. So the previous value. Okay, 12. And next one is also you will get 22. Okay, for 3, 4 I will calculate. Okay, so here F3 to 12 and this value will be F3 comma 3, 22. And 3, 4 we will calculate max F of Okay, 2, comma 1, 2 minus 1, sorry, 2. Okay. So, 3 minus 1, 2, comma 4, okay, comma V3 plus F of 2, comma the weight, okay, the weight 4, the weight 4 minus this weight 3, okay, 4 minus 3, 4 minus 3, 1, okay, 1. So, F of 2, comma 4, 2, comma 4 is 22, comma V3. The value of this third item is 20 plus 2, comma 1, 2, comma 1, 2, comma 1. What is the value of 2, comma 1? F of 2, 1, 10. So here it is, the maximum value is 30. So 30 is the, so here you have 30. Okay. And here you will have 32, 32. Okay, 32 value how? The maximum of this value, okay, 22, comma. Okay, the maximum are the V1, V3 value 20, okay, 20 plus. Okay, the weight is 5. This weight is 3. 5 minus 3, 2. So 2, second column, 12. So 12, which is 20, 20 plus 12, 32. So 32 is the answer. Okay, 32. Okay, so next, the last one. Okay. So here we have all the values 0, 0, and here you have to calculate this value. So for this value, you have to consider this, okay, the maximum of 10, comma, okay, the maximum of 10, comma, and here the weight 1, okay, the weight is 1. The value of this fourth item is 15. Wow, 15 plus, okay, 15 plus 1 minus 2, negative. Okay, 1 minus 2, minus 1. So don't consider. Okay, so 10 will be the value. So here you should write 10. Okay. And the next one, 4, 2. 4, 2 you have to consider this 22, comma, value 15 plus, okay, 2 minus 2, 0. So previous row 0, 0. Which one is maximum? 22. Which one is maximum? 22. 4, comma 2, 15, 12, 15. Wait. Wait, let us calculate it again. I have a doubt. Okay. So 4, comma 2, you have to consider the previous value 22. 4, comma 2. Previous value 22. Sorry. Oh, it is 12. I only made a mistake. See, we have calculated. This is 12. Sorry, pa. So here you should put 12. Okay. This is 12. Okay, 12. So now the previous value is 12, comma, okay, the weight is 15 plus 2 minus 2, 0. Okay, so 0 value is 0 here. So the maximum value is 15. You should write 15 here. Okay, this value, okay, this is 15. And 4, comma 3, this value, so 22, comma, okay, 15 plus weight to be considered is 3. And here weight is 2. So 3 minus 2, 1. So here what is the value here? 1, 10. So 10. which is equal to 25. So here you should put 25. Okay. And 4 comma 4. For 4 comma 4, I minus 1 comma j. Okay. The previous value 30 comma 15 plus. The weight is 4. 4 minus this weight is 2. So 2. So second column 12. Okay. 12. This is 27 and this is 30. So what is the value here? 30. Okay. And next, this 4 comma 5, this is our final result. So here 32 comma 15 plus. Okay. The weight to be considered is 5 kg, 5. But weight of this item is 2. So 5 minus 2, 3. So third column previous row, 22. So write 22 here. So 15 plus 22 is 37. 32. So the answer 37. Okay, 37. 37. So this is our final answer. This table, what is the index? F of n comma w. F of n comma w, that is f of 4 comma. Okay, here the index starts with 0, no? So 4 comma 5. So this is the total weight. Okay, total values. Okay, values of the items that can be put into the knapsack. Okay, how do we find the subset now? We have gone this one. So how do we find the subset 1, 2, 3, 4? By using backtracking technique, we are going to find whether which items should be included into the subset or not. So here 37. Okay, this is the maximum value we can have in the knapsack by putting some items. What are the items? Okay, 37. Okay, here the fifth column, 5, this is the weight, maximum weight. So 37. 37 is for the fourth item. Okay, is for the fourth item. So you include 4. You include 4. Okay, 4. Okay, fourth item, the value is 15. 15. Value is 15. Okay. So the weight is 2. So total weight of the bag is 5. So 5 minus 2 is equal to 3. So remaining 3 kg, we have to find which items should be included. Okay, go to previous one. So 3. So go to this third column. Third column, what is the value here? 22. This is the value maximum. Maximum value 22. This, of course, we have already included. Fourth item. So 22. So this 22 of the item 3. But see, this f of 3, 2, 3 is greater than 3, 3. We have already got this 22 in the previous row itself. So you need not to include this third item. You just include this second item. So here 0 and include this second item 1. Here 0, second item 1. So 1. Second item we have included. Okay, second included, 4 included. So what is the weight of this second item? 1. Okay, so 3 minus 1 kg. Remaining is 2. Remaining is 2. So next you have to go to the next one. So this you have selected. So next 2 kg. Here you come. Here 12. So 12. The previous is 0. So 12. You can include this. So you can include this item 1. Item 1. Okay, here the weight is, the value is 15, and the second one value 10, and the first item value 12. So totally 22 plus 15, 37. So the maximum value of the knapsack is 37. And what are the items to be included? 1, 2, and 4. 1, 2, 4. Okay, 12, 22, 37. 2, 3, 5. So this is how you can find the knapsack problem solution. So here this is the table which gives you directly, you can write. Okay, so let me fastly write this. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And here this is 1 kg and this is 2. So here you cannot have. So 0 and 12, 12, 12, 12. And here 2, 1. So here 2, 1. So here 0, 0, 2. So this one 2, 1, 0, 1, 0. You can have, yeah, 1, 1, 0. And how this is 12? Consider this 12 and 3, 2 minus 1, 1. So 1, 0, 0. So here you can have 12. And here 12 and 10 plus 3 minus 1, 2. So second one, so 22. So directly you can write something like, okay. And here you can have 10 and 3, 2. So here the weight is 2, 3 minus, so the same 12. Here 22, 3 minus weight 0, so it is 0. So here you can have 22 and here 30 and 32. And for example, this 1, this is 2, so the previous value. Here 12 plus 15, so 2 minus 2, 0, so 0, so 15. So here 25, 30, because 30 and 4, 4 minus 2, 2, so 1, 2, 30, and here you got 37. Okay. So now you can have a C program, so which gives you the same execution. 1 minute. So control R, run. So same program, same values I have given. So we have got the result. So you can see change any values here and see the values. So let me check. This is 5. Something is it. Then you change and you will find some other value, something. Okay. So the same algorithm is converted into C++ program and we have got the solution. Thank you, students. All the best.